Good morning, everybody. This is about the sampler project, the PowerShell module toolbox and template for continuous delivery of PowerShell modules. My name is Raimund. I'm from Microsoft Germany. I'm previously a PFE, now called customer engineer, and my day-to-day business is all around PowerShell and DSC. And this will be about the sampler project created by the gentleman here in the front, Gail Kolas, and Johan is helping him very much. And it's all about getting your code in a high quality onto the PowerShell gallery or whatever gallery you want to use effectively and easily. So the session objective is that afterwards you have a kind of toolbox or a framework that you can use to raise your code quality and also your cadence. You should be very it should be very easy to release new code to galleries in a completely automated fashion. What is sampler? So the project describes itself like this project is used to scaffold the PowerShell module project complete with PowerShell build and deploy pipeline automation. So that's taken from their own webpage. And I started using sampler, I don't know, 2 years ago, 1 year ago, and it immediately caught my attention because it was forcing you to write code in a way and deliver code in a way that we should have all done it previously, but most, I think, didn't do. So who is writing PowerShell modules on a regular basis? Okay, fair amount. Do you use a release pipeline to get your code into a repository, or how do you share the code? PowerShell Gallery, okay. And the release process is fully automated? Building it. Okay. Who is still using file shares internally to distribute PowerShell code? Or have it on some kind of, yeah. Do you guys have an internal gallery, or?
We're working on one now.
Okay.
But we don't have anything up and running yet.
Yeah. That's my experience as well. So most customers I'm dealing with and from the enterprise area still don't have a local repository. They are dealing with the old ways of sharing code, which comes with a lot of problems. And we know the problems, right? Versioning, teamwork doesn't really work very well, discoverability, and so on. So first of all, sampler forces you to start with a high quality or high code quality right from the beginning, because there are a lot of tests that are running over your code and making sure that the code is as expected. Not only functional-wise, because we have pester tests, but also from linting aspects. So is the code according to the standards that we have? And most teams, most companies don't even have a coding standard. Everybody writes like they used to. And with this stuff, we can have our scripting analyzer rules as part of the project and make sure that the code is always in the same order. Sampler is pretty good extensible. We will see later how easy it is to put your own requirements and your own workflows into the sampler project. And it runs on all operating systems that are supporting PowerShell. So later we will see that the tests that we are running in parallel on Mac OS, on Linux and Windows PowerShell 5 and 7. It runs on all common CI/CD products, so it's not something that is only running on Azure DevOps or whatever. It is pretty flexible in this regard, and it provides, and that's very important, a single entry point. So the only script that you have to trigger to create a build is running the build script, and the rest is then orchestrated from the build script. So sampler is used heavily by the DSC community. They have 50 modules that are currently adapting this pattern, and I have shown it a couple of customers, so I think about 20, 30 enterprises in Europe at least, I don't know how it is here in the US, are using it internally for their module deployment as well. Good. So, what sampler brings together? I think many of you know tools that are, for example, task runners. We have Pisaki, we have Invoke Build. There are a number of different other solutions. Testing and linting can be done by Pester. So the question was here, how do we bring all the stuff together in a way that you don't need to find out how all the individual technologies are working, right? So you just use sampler and you get this all for free because it's all already connected with the project that you're going to create, right? Let's dig a little bit into some of the points here. Why is a task runner important? So a task runner in PowerShell is pretty similar to the task engine that you have in Azure DevOps or in GitLab or in Jenkins. So you can create a bunch of tasks. Tasks can have dependencies. Tasks can have parameters. But as long as you define the tasks in your automation system, Jenkins, Azure DevOps, and so on, you're pretty bound to that automation system. So we want to be independent, and this is why a task engine running in PowerShell is doing pretty much the same like a build engine in an automation system. And you can then take your tasks and move them to whatever system you would like to run this on, and it just works in exactly the same way. We will see later what kind of tasks we have. Testing and linting is done, testing is done using Pester, code coverage as well. I think everybody know how Pester works, right? But here we have also a very good integration into the build process. Linting the same, PS Script Analyzer is started and looking at our output and makes sure that the output is as expected and according to our code quality. The publishing is just PowerShell code, right? So we have a couple of commands that are interacting with the gallery and pushing the results there. Dependency resolution. Why is dependency resolution so important? How do you deal with it? Some of you said that you have also PowerShell modules deployed by a pipeline. How do you, or do you use dependency resolution? Anybody? Or how do you make sure that the build process has all the resources it needs in order to actually do the build? Run and see if it fails. Yeah, there was a gentleman at the breakfast table, and with the T-shirt, "It runs on my machine," right? Yeah, and this is exactly what we want to get over with dependency resolution, so that the project defines itself what it needs to actually run the builds and have a predictable outcome. Yeah, so we will see later what dependency resolution means and why it is important. We have a templating mechanism. We use Plaster for that, and the templating mechanism is a very easy way to create you a kind of startup project that you can extend later. What is very nice is changelog control. It looks like a very tiny part, but if I think back, most of my commits, not even all my commits, ended with, or all my PRs, ended with another commit that was updating the changelog, because I always forget to update the changelog. And if this solution wouldn't remind me to update the changelog, I would forget it completely, right? So some mechanism makes sure that there is something in the changelog that describes whatever your PR or commit is about. Quite nice. We have automatic doc generation, so that means that the comment-based help is taken and converted into markdown files that are then part of a project. We have automatic versioning, which is Git version. We will see later what that means. And finally, we are having the module builder. Module builder is the piece of technology that takes all the files and creates one large file that is much easier for PowerShell to deal with. Good. Let's go into some of these things. So the rest will be pretty much a demo, and we are starting with the task runner. So let's create a project, an empty project first, just to give you an idea about the structure. Get module list available sampler. So we have the newest version here, 112.3. And the most important command, if you want to get started, is new sample module. Destination path is D. Module type. We have a complete sample, something that is primarily done for the DSC community. Simple no build, so let's go with the complete one. The module author is me. The module name is test1. The module description is none. Module version is 0.1.0. And we have a license type, Apache MIT. That's all it requires. And if you hit enter, then it asks you, what is the name of your main branch? Nowadays, it's not master anymore, it's main. Here we go. Who is the organization that is going to publish the module? So this is only making sure that if you are not inside your organization in Azure DevOps or in GitHub, then you're not publishing the product, right? It's more or less controlling when we are going to actually do the publish and when not. So it's my organization. And we want to have automatic versioning using Git version. We want to have code coverage, and that's it. And then you are getting a nice little structure. Drive. Test one. Okay, that looks like this. Yes, we trust it. Okay, so we have our templating in here for GitHub. We have some VS Code files, the script analyzer rules, some settings, the tasks. We have an output directory, which is pretty much empty. Right? This is going to be filled if we are starting the build process. And all our stuff is in the source folder. And in the source folder here we have a template that contains everything, classes, DSC resources, and so on. So the next thing after having done this is cleaning it up. Right? Usually you start, maybe you start with DSC resources, but I guess your first try would be just creating a normal PowerShell module. So you remove the classes, you remove the DSC resources, you remove the enums, and then you are only having your private and your public functions. And with these ones, you can start and can add your own code. If you remove classes and DSC resources, of course, you also have to remove the tests, because otherwise the tests are trying to test something that doesn't exist anymore, right? Yeah. So I guess the cleanup process usually takes 5 to 10 minutes. You clean up until there is nothing red anymore, and then the build is usually going to work, right? So this is already working in another project. In this one. I'm not starting completely from scratch because I'm not always trusting the PowerShell gallery. In my last demo 2 weeks ago, I tried to do it from scratch, including downloading the dependencies, and it didn't work anymore because the PowerShell gallery was down. So, dependency resolution. This is pretty important. Why is it important? Remember the t-shirt? It works on my machine. So you have modules in program files, you have modules in your personal module folder, and these are not the modules that we actually want to use here. And we don't want to download, just for the build, modules into program files or into your personal module scope, right? So the build process, the whole build environment should be something isolated. We don't want to pollute your machine. This is why everything that is defined in required modules PSD1 goes into the output folder and required modules. That means you can easily just delete the folder, start from scratch after you have maybe changed the versions or you know that there is something new available on the gallery, right? If you are starting with a clean project and the output folder is empty, then the first thing that the build script automatically does is downloading the dependencies and getting ready to go, right? So this is the step that I already did because it also takes a couple of minutes. Then this folder, $env ps module path splits. It's already in here. Let me create a new shell. Yeah, so here we have the standard PS module path, as you have it on your machines as well. And if you kick off the build script, then we can just start it like this, then the whole build process would work, or we can start it in a kind of initialization way, which is the task no operation. Here we go. And this is just configuring the environment so that we are be able to debug our own code. So you could even have built the module a couple of hours ago, you close Visual Studio Code, you open it again, and in order to configure the environment to run the pester tests and actually load your module, you just need to prepare the module path and some other properties. So and if we have done build with no op, then our module path looks like this. So the module path points now to the output folder, to my required modules, which makes sure that all my dependencies are actually discoverable, because previously they have been just downloaded but haven't been discoverable. Right, so yeah, let's just start a build and see what's happening. And the build will always clean the output folder first. Right? Except the required modules. We don't want to download the required modules every time we build, so we keep them, but there is also a task to actually remove everything that we have in the output folder. And here we go. So the output looks like this. We have our docs generated, we have the help, we have our required modules as downloaded previously, we have the module, Summit test 1, that has one PSM1 file, one PSD1 file, and module that is kind of injected. I'll show that later where this comes from. And yeah, that's it. Plus the changelog and the release notes. So this is the standard output of every module or sampler module project if you trigger the build. How are we creating the PSM1 file? Let's have a look how the PSM1 file looks like. It starts with a reference to my private files. Get private function. There is my private function, and it also contains a reference to the line number. We see this is coming from line number 1, going down to private, get private function, line number 32. Then we have our public function in here, and that's it. So that means every function that is in the source folder, public, private, is being added to the PSM1 file. However, the public and private folder has a meaning. So that means the private functions are not being exported, and the export is controlled in the PSD1 file. So the PSD1 file, somewhere down here, has the functions to export key, and the function to export key only contains the functions that you have put into the public folder. The rest is hidden, right? So quite easy to deal with function visibility then. Yeah. Anything else about how the file is created? Any questions so far? Please.
How do we handle things like classes and enums?
Remember, in the project that I've created, just for testing purposes, oh, no, the wrong one. Here we've also a folder for classes and DSC resources, right? So it's not only modules or scripts that you can handle here. It's also possible to do classes, enums, and DSC resources.
Those get compiled correctly into the module or something.
Yeah. Yeah. So just to repeat, the question was, can sampler also deal with classes, DSC resources, enums? Yes, it can, and these things are also added to the module output. Any other questions? Yes.
Two short questions. One is, what if it would be hundreds of functions instead of private public? Any limitations there, or just all done into PSM1?
I haven't faced any limitations yet. Gail, have you faced any? No. Yeah. Yeah.
Okay.
It just takes longer. Yeah. Yeah.
Is it better to dump them into PSM1 or keep them separate still on the files and source them?
So the dot sourcing, or let's put it that way, right? So a couple of years ago, there was not this kind of best practice. And if I go to one of the modules that we have created a long time ago, come on. So we have a module that consists of a bunch of public and private functions, and these functions are dot sourced. Which, bigger, sorry. Yeah. And these so this module really is in the shape as displayed here on the browser. So we have, I think, 200 PSM1 files. We are shipping 200 PSM1 files. We are dot sourcing 200 PSM1 files every time you import the module. And this takes 6 to 10 seconds. So you don't want to dot source many PSM1 files. This is why Module Builder takes all the PSM1 files during the build time and puts them into one big module, right? I mean, from a source code management perspective, having one huge file is extremely bad. We don't want this. So the good thing is that the sampler allows you to treat your source code in individual files, but merges it to one big file, so the loading time is way more efficient. Yeah. Did this answer this question?
Yes.
Good.
One more.
Yeah.
Which modules did you use to build and to use dependency? PSDepend?
Yeah, PSDepend is used for, here we go. Where is it? Required modules. No, this is the other project. Here we go. If we go to required modules, then you can see this is the stuff that we have downloaded in the background. And PSDepend is right here. Yeah. So the dependency resolution is done with PSDepend, and the module merging is done with Module Builder. Yeah. So this is the nice thing. You all heard about these projects, right? Module Builder is pretty well known. PSDepend is in the wild since, I don't know, since years, right? And Sampler is putting this all together. So for me, this was kind of eye-opening because I knew all these technologies, and at one point in time, I wanted to implement them eventually into my build processes, but we know we don't have the time for that. And Sampler just does it. You can just use a predefined pattern, move your source code in it, and then you are benefiting from all the stuff that other people have already programmed and proved that it's working.
So this is like, it's not compared to stuck a sampler is, but is sampler and stucco, can we use for the same thing?
I wanted to listen to the stucco talk, but unfortunately it was cancelled for some reason. Yeah.
Okay.
So Gail, do you know how stucco compares to a sampler?
Yeah, so there's three main things. So there's press, I don't know if Justin around, but and then this is sampler. I would say at least Brandon and myself, we tried it at the same time, but he was more like a cycling guy and I was more an info build guy. That's the task runners. So we just went like slightly different ways, but the principle is the same. And then we have very similar background, and we actually talked when we were building it. So anything works. That's a slightly different. But I think he uses plaster as well for the thing. So it's very very similar.
Seems like every time you have output, you have a bunch of modules repetitive for every project, right? Or is it, what's the inside the output? So
You mean inside here?
yeah. So this is one project.
This is one project, yeah.
So then you're creating another one. It will be also containing all the same modules.
Yes, according to whatever you have in your, where is it? In your required modules, right? So yes, there is an overhead. You're storing files over and over again, depending on how many projects you have, but that's the only way. Because at the end, we don't want to build this in our local box. We want to build in the build pipeline, right? So the build worker needs to get hands on all these modules, and therefore, they need to be downloaded. But it never really disturbed. It's about 200 megabytes. It's quite fine. And afterwards, will be removed.
You're not publishing that to the gallery, the output with the cached modules, correct?
We are just publishing the module that we have built. So only this is published, not the rest.
But the rest of it is in your build pipeline.
It's only the build pipeline, yeah.
And also in the source control.
And no.
It's ignored, right?
Yeah. So here we have the git ignore file, and the git ignore file defines that everything in our output folder is not of any interest, right? The output folder contains the artifacts. The artifacts never go to source control, right? They are getting to an artifact gallery, yeah. Okay. So, yeah.
I can see you're still using test 4. Is there anything about test 5?
Yeah, timing. Yeah. So merging the tests is not as easy as you always want. Yeah.
But
There was a comment? Yeah, it does. Yeah.
So I'm already using build module. Is there anything I need to look out for when I implement this? I know I have a build.psd1. See you have build.ps1. Is there anything that I need to look out for when I use this?
I don't think so. No. Do you have anything in mind? Is there any bad thing that you can do when moving your source code into sampler?
If you're already using module builder, then you already have the source folder.
Yeah.
You need to add, there's 3 or 4 files. So build.ps1, required modules.psd1, it used to be the PSD penway, and then there's like 2 other files, I think, like another PSD1, and the build.yaml.
Okay. So, but if I run that scaffolding, the original new sample module will do it for me? Are you saying I need to individually do that?
No, you can do both. Up to you. You can just apply it's plaster. You can apply on top of it, and then it will tell you destructive.
Good. Let's go into the next spot here, testing code coverage, right? So after having built the module, you have seen that the pester tests are being invoked. We see that here, that they are checking our build. It's all about fail fast, right? So we don't want to having this fail in the pipeline. We want to see if this fails locally first. If it fails locally, we don't even push to the pipeline. But of course, all the pester tests are running there as well. So if I, for example, get into my public function, and in the public function, I am, I'm not returning the data that is expected, but returning something else. Then the whole thing should fail the next time I'm building it. Yeah, here we go. So output is not as expected, and therefore the build failed. Perfect, that works. Another thing that we can do is, and actually it fails because something is wrong with my docs here. Let's build it again, hopefully successfully this time. And by the way, if you do a debug, so if you are using this product, it costed me always a couple of minutes or even hours, don't debug the output, or no, don't debug the source folder and set breakpoints in the source folder for obvious reasons, right? We are not debugging the source, we are always debugging the output. The problem is, if you kick off the new build, then the output folder is cleaned, and you're losing your breakpoints, and you're losing all the modifications that you have maybe done to the output folder to tackle down the issue, right? So, if you have built the module already, and you only want to test it, what you can do is call the build script and run individual tasks. So you don't need to run the whole pipeline always. You can select tasks that you just want to invoke for debugging purposes. And the question is, which tasks do we have? And if you invoke the build script and you get to the task with a question mark, then it will print out all the available tasks that are defined in the sampler project, right? And one of the tasks is, the task name is sometimes a bit weird. This one, tester fail. This would be one of the tasks. Let's see if this works if we call this directly here. Yeah, and this is only invoking the test. So it's not deleting the output folder. It's not building the module from scratch. It's just invoking the test that runs over the previously created output. What we have here is also a definition of tasks. So sampler comes with a bunch of standard tasks, but bringing these standard tasks into a sequence, that's your job. Or at least you can modify the sequence. And the sequence is controlled in the build YAML file. The build YAML file, first of all, defines which folders we want to additionally copy into our module. So there was the question about classes, right? So if you want to have a bunch of classes in your source folder and you want to have these classes just copied into your module output, then you just have to specify the copy path here. And here we have also a copy path of the modules folder. And that's the explanation why our output has output, there is my module, and it has a modules folder. And the modules folder just contains one file. And this file is just coming from source. Source, modules, folder, common PSM1. It wouldn't have been copied if there is not a reference in, sorry, I've closed it accidentally. It wouldn't have been copied if there is not a reference to the folder in here, right? Let's go back to the tasks. So we have a build workflow that defines that there is a build task and the test task. And the build task contains, well, first, cleans the output folder, then does the module builder, then if nested modules are available or referenced, then these are processed as well. Then we are doing the changelog output, creating the MAML files, and then we have done the build, right? And the next step would be going into test. Here we have our test task. The test task does run the tester stuff first, then code coverage, and then we're done. So if you, for example, don't want to have code coverage, then you can simply remove these tasks from here, and you are then just down to normal tester tests, right? Or if you always want to have the tests as part of your build for some reason, then you can also move this section to the build and remove the test. I wouldn't recommend it, but just in theory, right? Or if you have other tasks that are not part of this already, then you, of course you can define your own tasks as well. So this is pretty customizable. And if you have something, for example, that is not covered in Pester yet, then you can simply create a new folder, .build. And inside the .build folder, we are creating a file, which is called something.ps1. And then here we have a task, which is my task. And the only thing it does, get date, right? And if you run the task discovery another time, so it was build tasks question mark, then we should see it here, there it is, right? So that means if you have something, because your organization requires some additional processing that you want to inject into the sample build pipeline, just create a build folder, define the task there, and where the tasks are being invoked is then up to you. So it would be either something that you can call manually, my task, here it is, and there is my date, or you can go to the build YAML file, And let's say we have something that needs to be done here, my task, and then your task would be just exactly at that position as defined in the build YAML file.
What PowerShell code are you using to ingest the build.yaml internally within sampling?
It's invoke build.
Oh, invoke build it?
Yeah.
Oh, okay.
Okay. Any question on this task injection?
So you need to download the bulk build module and anything else to make it work?
No, it's invoke build is automatically downloaded via ps-depend. Yeah. So you don't need to download anything manually. You just need to trigger the build script, and the build script is getting everything in your build environment that is required to do the build. Yeah.
Including module to build itself.
Including module build as well. Yeah. And invoke build. Good. Let's move forward. What else do we have? Linting. Yeah, linting. Linting is done with this task here. We have the HQRM task. It's actually called DSC resource tests, but it works for any code as well, because the coding guidelines that the DSC community has invented is pretty good. So you can also run it against your code. And let's see if we find any issues here. HQRM. There was something. I'm not going into the details here, what we are testing, just into the single error that we have. And the error is, that two files do not have an empty line at the end, right? So in Git, there is the rule that every file should have at the end an empty line. It's not in here, so yeah, this would have been discovered. So something is wrong in the build process that creates the XML files. Sorry. So the linting process is exactly picking up whatever you have in your VS Code analyzer settings rules. So these are the rules that we are going to apply. If you're not happy with one of the rules, you can remove them. If you want to add more, it's also customizable. It's just VS Script analyzer. Good. Timing. Yeah. Let's go into templating changelog control. Yeah, let's do a changelog control. So let's say I'm going to make a change. Nope. And the change that I'm going to is, what do we have here? Something, yeah, edit this and, okay, good. Some change. And then we are doing the build again. The build should work. However, it doesn't work. Perfect. This is what I wanted to show. And it didn't work because the changelog hasn't been updated, right? It's only a tiny part that is being checked here, but I think it's very important because, as I said at the beginning, I always forgot to update the changelog. Now you're getting reminded, right? So you can't actually build the project anymore because there is no corresponding entry in the changelog. So what we have to do is go to the changelog. There it is. We have a format which is also standardized, and everything in the unreleased section is getting moved to a versioned release section, and the unreleased section is copied at the top again. So you are always dealing with the unreleased section. You enter whatever you have done, or you add whatever you have done, and you can be sure that when you release a new version, then things are automatically managed and put in the right order. So in this case, some change, and we should be fine again. So if it builds, then it doesn't. Because I haven't checked it in. Yeah. Updated changelog.
But you need to now update this one.
Yes, now it works. So it only accepts the change in the changelog if it is committed to Git, because this is how it finds out if the changelog has been touched or not. So let's push this. And pushing this should also trigger my build pipeline on Azure DevOps. Let's see. Not yet. Here it is. So this takes a couple of minutes, and we can continue with other stuff while it is building. And hopefully, after the build is finished, we go to the test. We will see that it's being tested on 4 platforms in parallel. And after the test, we should see that the module appears on the PowerShell gallery in no time at all, without any human intervention. That's what I hope to be able to demonstrate. Okay, so another bullet point here on the slide was, how do you guys do a versioning? How do you decide when and how to increase the version number of a project? Does anybody have an automatic way to do this already implemented? Okay. One.
I use semantic versioning for it.
Yeah.
So it detects minor changes, major changes, and patches.
Perfect. Depending on the commit message, or?
Using Marquette solution for a fingerprint.
Ah, okay. Good. Perfect. Here we're using Git version, and Git version can be configured. So we have one file in here. The file is the Git version YAML. Just to finish this up. So the build YAML file is the file that defines how the overall build process should look like. It defines how the pester tests are configured. It defines what kind of linting we want to include, exclude, right? So this is your main tool to control how the build works. If we want to control how the versioning works, then we go to the Git version YAML file. And here we have defined what are the key triggers to do a major, minor, or a patch version bump, right? So that means whatever you have the commit message or whatever your branch is called, we are doing either a minor, major, or just a patch branch. And this is also visible in the build pipeline. Did it already work? Yeah, you can see here that we are running version 0.1.0 preview 1+4. Yeah, I have done one build yesterday, and it would be increased every time we are running a new build. If we want to run, or if we want to deploy a non-preview build, then we are working with Git tags. It's a bit too much to discuss it here, but a tag is then, or the tag is the indicator that you have made a decision to release a new version, right? And yeah, this is how the versioning takes place. Good. Module builder, change control, publish. Publish is running in the background at the moment. Yeah. Anything else? Any questions so far while I'm thinking what to show next?
Can it be not Azure DevOps, but something else? Like
Yes. Yeah. So it runs on, I have a couple of customers running this on GitLab. Did you try it on Git Actions? Does it work as well? Git Actions?
It's tried, but we don't have a pipeline used in.
Okay.
But someone tried, and
Yeah.
we're
I mean,
not using it.
as I mentioned at the beginning, it's all about PowerShell tasks, right? We are not using the, well, let's have a look at the pipeline actually. This is the Azure Pipelines file. So all we do is we trigger Git version to calculate the next version, which is just a standard Azure DevOps task. So if you use another product, then I'm pretty sure you have something similar. And the next thing is, here, just triggering the build script with resolve dependency to make sure that we are always running, getting the dependencies, and then we are just packing the stuff, right? It's not triggering the tests, it's just putting everything together. And then we are publishing the artifacts, and that's it. So actually the build process is just this single task, and this can be invoked on any build system, regardless of what you use. Yeah. Right, and then you can see we have the next stage is test, running on Linux to just call the build script again, but this time only the test task. We are doing the same on Windows Core or PowerShell Core, and doing the same on Windows PowerShell, finally on Mac OS, and that's it. Right, and if all these tests have been passed, code coverage, uploading the artifacts again, then we go into deploy. The deploy task will only be done if the others have succeeded so far and if we are in the correct organization. So that makes sure that if somebody has created a fork, we are not trying to do a deployment, right? So it should only happen in the main repository. Talking about the main repository, what do we do here? We are still building, yeah. So this is pretty much depending on the mood of the PowerShell gallery. Sometimes it's extremely slow and it takes up to 30 minutes. Sometimes it's done in 2 minutes. Yeah. You should have a much better experience if you run the whole thing in your on-prem environment, targeting to an on-prem repository. Because if you want to download from something that is on-prem, then you can simply go to the PSDepend file and tell PSDepend to not download from the PowerShell gallery, but from whatever gallery you have created previously, right? So it's not targeting the PowerShell gallery always, it's configurable. Good. Yeah, this looks good as well. So the build has finished. Then comes the tests.
Could it be less files and folders, like in the initial scaffold? Because it looks pretty heavy solution.
Actually, it's not so many folders. You have tests, source, and that's it. So the VS Code folder is part of your project anyway, I guess, if you deal with Visual Studio Code. The GitHub folder is not required. It's only required if you publish your project on GitHub. And the build folder is only required if you have custom tasks that you want to inject. So the number of folders is, I think, pretty good. The number of files is, I think, the usual number of files that almost any open source community project has nowadays. So it's pretty hard to get rid of something here because most of the stuff is essential. What can we remove? Code of conduct, yeah. Security MD maybe, but also in an internal project, you want to be descriptive. You want to have these files to tell people what this project is about and what the rules are. So in this case, I would say not very much. Yeah. Any other questions?
Can you override the packing and not pack your functions? You keep them in separate files?
You mean, is it possible to keep the output folder and not override it? Yeah, you can, but then you have to just modify your build YAML file, and from the build task, here is the build task, you just remove the clean. But I wouldn't do it. Why would you not clean the output folder when triggering a new build? What could be the reason for that?
Well, I want to make sure that people that want to look at my open source code can use it.
Yeah. Yeah.
And I separate them into different files because it makes it easy to find things.
I think he's asking something different.
I think so.
The combination, when you take the PS1s, you combine them into the PS1s as part of the build. He's asking you to keep the file separate, right? Yeah.
No, why would you?
Because I've got functions that are categorized in families.
Okay, but if you categorize functions, why not using this? Why not using a name prefix for that? So I would do the categorization by a naming convention and not by the file name. Yeah. So the problem is if you have hundreds of functions and you dot source them, the module load time is pretty bad. This is why we put everything into one function, into one PS1 file.
I feel like a volume where I've got all my gets and sets and deletes and actions and all that for volumes. But I don't want to mix them in with the functions for dist or the functions for...
Sounds like separate projects, right?
No.
No, you can have subfolders to your private and public. So you can have subfolders, so then you have categories in them. So in the private folder, you can have, I don't know, I do that for, when I have package management, and then I will have, a dozen functions there. Then I have another folder, which would be file management, and that would be another dozen functions. So you keep them separate, but then at the end, it still merges everything together.
Does it clean up that directory though?
It's the source.
The source, yeah.
The source is being built into one piece and one function.
Yeah, you're talking about two different things, right? You give them access to the repo to see all the functions.
Yeah, you're still going to see it all.
Yeah,
The module, you don't want them to like open the folder and look through the code that way, right?
Yeah, in your source, it'll still be separate.
Right,
When
right.
you build it for publishing, it combines it all.
So yeah, if they look
Yeah.
at the repo, it'll still have the separate files. This is just for the build process. Yeah. The
difference is do you want your end user to look at the artifact that's built or the source code that you're building before you ship an artifact to PS Gallery or wherever, right? That's going to be your determination. He's showing how to ship it without the source code compiled with separate scripts, right?
Yeah. So the lesson here is that the source never looks like the artifact, right? So the artifact is something that is optimized for performance, and for usability, and the source code is optimized for manageability and readability. Yeah. Good. So let's go back to our pipeline. Pipeline almost finished. And let's see what the deploy does. Of course, I have kind of prepared the pipeline a little bit. So I have, let's go to the deploy task. And the deploy task is in here. Output, I will explain later what that means and why I am looking into the required modules. Sampler, tasks, then we have our deploy. No, that's the different one. Where's the publish one? Release. So, and here we have our, okay, this creates the changelog release output, and somewhere down here we are doing the actual publishing to the PowerShell gallery. And this only happens if there is an environment variable called gallery API token. Right? In this case, we have two tokens, one for GitHub to do a publishing on GitHub and to interact with GitHub, the other one with the gallery. And of course, you need to populate the variables into your pipeline, otherwise the publishing wouldn't work. So let's see. Deployment started. It's a bit small, I guess.
What GitHub? What token from GitHub?
Just an access token, personal access token.
Oh, to publish to GitHub,
yeah.
Not to GitHub.
So because the solution or the sampler pipeline is creating a pull request for updating the changelog, and for that you need a personal access token. And of course you also need a personal access token to be able to publish to the PowerShell gallery. And let's see. This doesn't look bad. And go also to the PowerShell gallery.
And you obviously can change the public gallery to your private.
Of course you can, yeah.
When you define the version, your commit, what did you actually put? Did you show us that? Or did I miss it?
The version number, you mean?
Right, so it's going to auto-increment
Yeah.
when you committed,
Yeah.
is that right?
Yeah, we will see in a minute what comes to the PowerShell gallery. But for some reason, I have trouble with my browser, and I always need to type the address manually, and the search doesn't work anymore. Publishing worked. Sending the changelog. Okay, perfect. So here we go. How was our module called? The module was called Summit Test Module 2. So let's see if we find this in the PowerShell gallery. Sometimes it takes a couple of seconds until it is discoverable. But again, it's really slow. And this is a bit weird, right? Total package is 0.
There was an email yesterday about the gallery being slow.
Again. Yeah, so I think if we have trouble with the gallery, then it might take a little bit longer until the module appears here. But if we can see, the pipeline has done the publishing without any errors, so that means that our module will be there.
You have Summit Test Module 50 from yesterday.
Yeah, yeah. One more time. Yeah. The PowerShell gallery is always the weak spot if you want to do a demo. I should have gone to my on-prem environment, but yeah. One more thing. PowerShell gallery. Just.
If you're publishing to an internal repo or gallery, is it set to pull in all the PowerShell gallery, public gallery modules into your actual module?
So what most customers do is they do a republishing. So you have the requirements, you select the versions that you trust, you publish these versions into your internal gallery, and these are the versions that you're good with for a couple of times.
It's the same experience.
Yeah, exactly the same experience, indeed. So manage packages. What packages do we have here? Published. There it is. For some reason, the search engine didn't find it, but here it is. And you can also see the version number here. And the version is, preview 1, the first release that we did so far. And with each release, we will increase the preview version. And if we do by indicating with a commit message that something else has changed, then we are also doing No, we are only increasing the minor and major version if we have released something already using a git tag action. Yeah. Yeah. This is it, right? We have one tag because we have one release. The tag is 10 on preview 1, and this is the basis to calculate the next version number. Right? So each release results in one additional tag in our Git repository. And this also works on Azure DevOps. On GitLab, it doesn't have to be GitHub necessarily. Right. Good. Time's up. Perfect.